Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat remarkable discovery coming from the object you see right here. A somewhat famous object in the constellation of Hercules that scientists have studied for decades. This is a galaxy known as Markarian 501, or MRK 501 for short. And it's an elliptical galaxy approximately 450 million light years away from us, and is technically classified as a blazar, or basically an extremely bright object whose emissions are the result of the active black hole in the center. But because the jets are pointed almost directly at us, it appears much brighter than anything else. And the reason this object is so famous is because it's essentially one of the brightest objects in the night skies when it comes to very powerful emissions such as gamma rays. As a matter of fact, if you look at a typical gamma ray map, that usually contains a bunch of bright dots. Despite most of them being neutron stars, some of the brightest ones are actually distant blazars, and one of them is Markarian 501. And for a very long time, this galaxy was essentially famous because of its powerful outbursts, and mostly because of extremely powerful gamma rays it produced once in a while, especially because it very often went through very rapid changes, sometimes occurring within just minutes. And that's because at its center there was always believed to be a supermassive black hole anywhere from 900 million to 3.4 billion solar masses in mass, which is how all of these emissions were produced. But the thing is, none of this was really discovered until 1996, and so it was only in the late 90s that scientists finally figured out what this object was. But, based on some of the recent observations, even these assumptions might have been slightly incorrect. Because this recent study you can find in a description discovers something else remarkable about this object that potentially makes this one of the most exciting galactic discoveries in the last few years. And so I guess let's discuss what makes this object so special. Now first, all of this is actually based on approximately 23 years of radio telescope data that allowed scientists to see this in a slightly different way. In other words, instead of focusing on gamma rays, they focused on the radio light, which is very often also produced by powerful jets coming from central black holes. And so when they analyzed this in radio light, they realized that it seems to have two separate objects. Instead of one supermassive black holes, there seem to be two extremely close to one another. As a matter of fact, they're orbiting so close to each other that they have a very high chance to merge in human timescales, possibly under 100 years, maybe even in just a few decades. And as you can imagine, if confirmed, this would make this an incredibly important galaxy, because this is the first time in history that scientists detected a kind of a double jet that seems to be formed by very close objects. But before we discuss some of the additional details, let's first discuss the basics of this object and what scientists have discovered about this in the last 30 years. Now first, why Markarian? Well, it's actually because it was originally discovered by the Armenian astronomer Benjamin Markarian in 1974. And he's discovered a lot of objects, so many of them contain his name. Although back in 1974, when he found this, he actually had no idea what this was. He just identified it as a massive source of extremely high energy light. And so it was not until late 1990s that researchers figured out exactly what this was, and especially because of a major emission in 1997. Here it had its most famous outburst. It became the brightest object in the entire night sky in terms of very high energy gamma rays. Although this did not last very long. But there was also this one mystery about it. Its radio structure did not make a lot of sense. And so when astronomers looked at this galaxy with different types of telescopes, they realized that for some reason the jets always seem to change direction or misalign, as if they moved further away from the center, with some researchers suggesting that it might be caused by some kind of a helical jet, or basically a jet that's shaped like a corkscrew. But other astronomers suspected something else. Maybe this was not a single black hole, but instead an elusive binary system, and specifically a very tight binary that's going to collide very soon. Okay, let's clarify something. In many previous videos we discussed black hole collisions that have already been confirmed by many different studies, which usually involve very small black holes, something that's under 100 solar masses in mass and very likely formed as a result of a supernova. But in this case, we're talking about very massive black holes, hundreds of millions of solar masses in mass, that existed since the beginning of the universe. As a matter of fact, there's a famous paradox. It's referred to as the final parsec problem. The idea that, technically, when certain supermassive black holes reach the distance of about 3 to 4 light years away from each other, they might actually permanently get stuck in this position because there's nothing that would pull them any closer. You can learn more about this in some of the videos in the description, but in a nutshell, mathematically, black holes should get stuck in this position and always orbit in the same position unless something very specific causes one of them to collide with the other black hole. Yet we know that black holes seem to collide because quite a few of them are very large, so somehow they seem to overcome this paradox and produce these massive collisions. But here the goal was always to find at least one galaxy where the black holes are so close that they're definitely going to collide, and possibly collide in just mere years, not millions of years. Which is of course why this particular system is suddenly so exciting. Because something in this case allowed these black holes to overcome that final parsec problem, and something helped them lose energy and decay their orbits enough for them to now orbit very close to each other. Now at this point nobody knows exactly how these black holes got so close, but based on this evidence, it looks like they're definitely going to be colliding relatively soon. Although in this case, let's discuss some of the details from the study and how scientists know all of this. And so in the study led by Silke Britsen from the Max Planck Institute for Radio Astronomy, they focused on the analysis of 83 datasets from the Very Long Baseline Array. And specifically they used some of the ultra-high-resolution radio observations that allow them to see features as small as a fraction of a milli-arcsecond. And what they found was essentially a second jet. Here it's referred to as Jet 2 and is visible in green. But it seemed to loop around the primary core in the anti-clockwise direction. In other words, it seemed to be coming from a separate source. And on top of this, there seems to be a kind of an orbital period. These two black holes appear to be orbiting each other every 121 days, which would imply a separation of about 250 to maybe 540 astronomical units, or less than 1% of a light year, or basically 0.001 parsec. But intriguingly, something else happened back in 2022 that potentially allowed the scientists to get even more data. Here, the second jet appeared as a kind of a ring-shaped structure, which you can sort of see in this image, that must have been produced by the effect we often call Einstein ring. In other words, it was something like this, but in this case the ring was formed by the jet. And so in this case, the gravity from the front black hole bent the light of the second jet behind it, producing the ring that was visible in radio waves. Which makes this an incredibly important discovery, because we've never seen two supermassive black holes orbit each other so close and with such a fast period. And importantly, this definitely solves that final parsec problem because it shows us two black holes at the final stages of this cosmic merger. And so this officially makes this one of the most important discoveries in terms of gravitational wave studies, galactic evolution studies, and supermassive black hole studies. As a matter of fact, in the next few years, as these black holes possibly approach each other just a little bit closer, we might be able to confirm that they are actually merging and even find out exactly when the final merger will occur. And so Markarian 501 gives us a direct look at two of these supermassive giants, hundreds of millions of solar masses in mass, that seem to be slowly approaching each other and are definitely going to collide in the next few decades. And based on how close they are and how fast they're moving, researchers are currently estimating that this final collision may happen in as little as 100 years and possibly even less. And so in astronomical terms, that's basically tomorrow. But obviously only future studies in the next few years will be able to tell us exactly when this will happen. And at the same time, this is also important for the gravitational wave sciences, especially in regards to the previously discussed gravitational wave background that was officially confirmed to exist all over the universe. In a nutshell, the entire universe seems to be sort of vibrating and shifting around, with the planet Earth almost acting as a kind of a buoy that seems to be bouncing around everywhere, as various types of waves pass through us at all times. This was discovered in 2023 and confirmed last year. And so this low-frequency hum that seems to be produced by gravitational waves across the entire universe can now be attributed to at least some of these supermassive black hole binaries, like the one in this system. In other words, as these black holes move around each other, due to their extreme mass and their somewhat close proximity, they very likely generate enormous waves with gigantic amplitudes. But in terms of frequencies, every single wave happens every 120 days. Either way though, Markarian 501 is now a prime candidate for very specific pulsar time array studies that can help us confirm if some of the frequencies and some of the waves are coming from this direction. As a matter of fact, here, it might be even possible to determine the exact frequency of these waves, and then to see if they're actually changing because the orbit is shrinking. Now the thing is, it will probably take a few more years of observations and measurements from various pulsars, and once again you can learn about how this was done in one of the videos in the description, but in a nutshell, right now there's a very high chance that all of this will be confirmed and measured in the next couple of years. But then there's the other important question. Can this actually be caused by something else? In other words, maybe it's not a binary, but some other effect or something else entirely. So could this second jet be something else? And here researchers did consider other explanations and tried to explain this in some other way, but also looked at what's known as Kelvin-Helmholtz instabilities, essentially the turbulence inside the jet. And so they actually found that it would not be easy to explain why the jet system shifted so much over the last 23 years, unless this was a binary system. And so right now, based on all of the observations, a binary black hole system seems to make the most sense. And in this case, the orbital plane seems to be slowly precessing or wobbling, kind of like a spinning top, which is why we're observing certain effects. And while our telescopes are still not powerful enough to see these as individual dots, we only actually see just one single object, the way that the jets are moving seems to tell us the entire story. And that means that this object, Markarian 501, has now transitioned from being a gamma ray mystery and one of the most powerful gamma ray sources to a gravitational wave mystery and one of the most important objects in gravitational wave sciences. Which means that we'll definitely be keeping an eye on this one, because I'm sure something else exciting will be discovered about it very soon. But for now, that's all I have for you. Until future studies, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.